Hi, I'm Brian Period tutoring high school physics. Today's topic, period and frequency of springs, or also the kinematics of springs. A period is the amount of time it takes for one thing to complete a cycle of something that's repetitive, such as perhaps orbiting the sun. One full cycle of that, the amount of time it takes, is one period. In our case, however, we're going to be working with springs, so the period is the time it takes for the spring to move from one position to another position and then back. So for instance, let's say you stretch out a spring past its equilibrium point and then you release it. It's going to go back past its equilibrium point, it's going to compress, and then it's going to come back. The amount of time it takes to get back to that original position is the period. You might also want to measure the number of cycles that a certain thing will be able to do per second. That's known as the frequency. You can find the frequency by taking 1 over the period. Period is represented by capital P, frequency by lowercase f. The units of frequency are seconds to the power of -1, also known as hertz. If you have the spring constant and mass of a spring, you can calculate its period using one of these two equations. You only need to memorize one because you can simply solve it and then invert it to find the other thing. So if you wanted, for instance, frequency, but you'd only memorize the equation for period, you could solve for period and then take 1 over the period to equal frequency. So let's do that. Let's try to find both the period and frequency of this spring, which I say has a spring constant of 5 newtons per meter and a mass of 1/5 kilogram. So we start out with the frequency. We have 1 over 2 pi times the square root of our spring constant, 5 newtons per meter, over 1/5 of a kilogram. And so we divide through and we get the square root of 25 seconds to the -2. And now we take the square root of that and we get 1 over 2 pi times 5 seconds to the -1, also known as hertz. And so we're simply left with that, 5 over 2 pi hertz. If we want to find the period, we could simply take 1 over the frequency, and since that's 5 over 2 pi hertz, we get a period of 2 pi over 5 seconds. Alternatively, we could solve this equation, which is a slightly longer process considering that we already have the frequency, but we could go through that nonetheless. We get 2 pi over the square root of 1/5 kilograms divided by 5 newtons per meter. T gives us 2 pi times the square root of 25 seconds squared. You see this pretty much the exact same thing. Sorry, 1 over 25 seconds squared. And then we have 2 pi over 5 seconds. Alright, to recap. The period is the amount of time it takes something undergoing a repetitive procedure to complete one cycle, such as orbiting the sun, or perhaps, in terms of the spring, going from one position to another position and then returning. The frequency is the number of cycles that takes place in a particular second. To find the frequency, you simply take 1 over the period. Frequency is represented by lowercase f, period by capital T. Frequency is measured in units of seconds to the -1 or hertz. To calculate the period or frequency of a spring, there are two equations. All you need are the spring constant and the mass. To find the period, you take 2 pi multiplied by the square root of mass divided by the spring constant. To find frequency, you take 1 over 2 pi multiplied by the square root of the spring constant divided by the mass. You only need to memorize one of these because if you can solve it, you can then invert it to find the result of the other. Alright, that's all for now. Again, I'm Brian Period. See you next time.